state. Physical state means they exist in the form of what? Solid, liquid, or gas. Okay, they exist in the form of solid, liquid, or gas that we need to study. So, yesterday we have seen that metals exist only in the solid state. Right? Metals exist only in the solid state, except there are two metals. Which metals? Which two metals are there which exist in liquid state? So these are mercury and gallium. Mercury and gallium are the two metals which exist in liquid state, except these two metals. All other metals exist in the solid state. Okay, in a similar way, talking about non-metals. So non-metals can exist in solid, they can exist in liquid, as well as they can even exist in gaseous state. Okay, non-metals can exist in solid, liquid, or gaseous state. All the three states are possible. Examples are also given here. For solid, you have carbon. Okay, you might have seen carbon. कोयला देखा है, coal, so that is carbon, so it exists in the form of solid state. Then other elements, so many elements of periodic table are there which exist in the solid state, like carbon, sulfur, phosphorus. And talking about liquids, so non-metals can also exist in the liquid state. The example is bromine. Br2 means bromine, so this bromine exists in the liquid state. And then talking about gases, so there are so many gases which exist in uh, the air also, like nitrogen gas, oxygen gas, hydrogen gas is there. So many gases are there which are non-metals and they exist in gaseous form. Then talking about luster, that is shine. So what we have studied yesterday is metals have shine, right? Metals have a shiny surface, they have shine. But when we talk about non-metals, so non-metals do not have shine. Non-metals do not have shine, but there are some non-metals like diamond. We know diamond. Diamond is made up of what? Diamond is made up of what? Diamond is made up of carbon, okay? And carbon is a non-metal. Means diamond is also a non-metal. So diamond is a non-metal which is having shine. Again, iodine is a non-metal which is having shine. Okay, so there are some non-metals which are having shine, but most of the non-metals are like they do not have any shine. Some non-metals are colorless while other are different colors. So this depends upon so many things, whatever it will be colored or not colored. Next is brittleness. So yesterday also I've given you one example that take a piece of chalk, okay? And what you do, you take a piece of chalk and you hit this piece of chalk with the help of hammer. Take a piece of chalk and hit the piece of chalk with the help of hammer. So what will happen? What will happen? The piece of chalk will break down into smaller pieces, right? It will get break down into smaller pieces. It will get converted into powder form. So this is known as brittleness. This is known as brittleness. So the solid compound, any solid compound, you can heat it. Sorry, when it is been hit by a hammer or pressure is been applied, so if it is getting converted into powder form, so this property is known as what? Brittleness. Now talking about the softness, so some non-metals are also soft and also some non-metals are very hard. Okay, some non-metals are soft and also some non-metals are hard. The example of hard non-metal is the diamond. Diamond is a non-metal, it is an allotrope of carbon and it is the hardest natural substance. Diamond is the hardest natural substance. Next is malleability and ductility. So can you tell me what is malleability and ductility? We have studied this yesterday. We have studied about malleability and ductility yesterday. So can you tell me? Yes, students, can you tell me what do you mean by ductility? What do you mean by malleability? Ductility means ability to make wire, ability to draw into wire, and malleability means ability to make thin sheets, thin layers. Okay, so if any material is able to be drawn into wire, then it is said to have the property of ductility. And if any material, any substance is able to be get converted into thin sheets, then it is said to be malleable. So non-metals do not have malleability or ductility. They are said to be not ductile. They are not ductile and they are not malleable. So if you hit any non-metal with hammer, so what will happen? It will not get converted into thin sheet. It will break down. It will break down into powder form. Understood? Any doubt is there? Okay. Now next is conduction of heat and electricity. So again, we have gone through this part conduction. So I want to answer from you all what is actually conduction. What is conduction? What is conduction? Conduction of heat and electricity. So conduction is to transfer heat from one end to another, and again the conduction of electricity means transfer of electricity from one end to another. So yesterday we have studied that metals are able to conduct heat and also metals are able to conduct the electricity. So whatever substance is, if it is able to conduct heat and electricity, then it is said to be a good conductor. And if it is not able to conduct, that is, if it is not able to carry the electricity from one end to another end, then it is said to be a bad conductor. Then talking about non-metals, so these non-metals are not able to conduct heat or electricity. Okay, so if you take any non-metal, suppose take the example of plastic. Okay, take the example of plastic. So if you have a plastic rod or plastic pipe, so and you try to pass the electricity from that pipe or from that rod, so what will happen? Electricity will not flow from one end to another. Or you take the example of wood. You take the example of wood. Okay, so if you have wood, a piece of wood, log of wood, and you try to supply the heat, you try to supply the heat, so heat will not be transferred from one end to another. Heat will not be transferred from one end to, if you are supplying heat here, so that heat is not going to get transferred here. So it is said to be a bad conductor of heat as well as it is a bad conductor of electricity. If you are supplying electricity here, okay, if you are supplying electricity from this end, electricity will not reach here, so it is said to be a bad conductor. It is said to be a bad conductor of electricity. Similar case happens with rubber also. So again, there are some exceptions. What do you understand by exception? Exception का मतलब क्या होता है? Here also you can see that exception is written, except graphite. Then in other parts also you will get some exceptions. So what do you understand by exception? If you carefully see the statement, what is written, non-metals are bad conductors of heat and electricity except graphite. मीन्स सारे के सारे नॉन मेटल जो होते हैं वो हीट और इलेक्ट्रिसिटी के बैड कंडक्टर्स होते हैं एक्सेप्ट ग्राफाइट, मतलब ग्राफाइट को छोड़ के. मीन्स ग्राफाइट इज अ good conductor, not only good, it is a very good conductor of electricity. Okay, Then talking about density, so they have low density, then melting and boiling point. So compared to metals that we have studied, that metals have nearly melting point, boiling point of 1000 across 1000 degrees Celsius. They have melting points. Okay. So, but when we talk about non-metals, the melting point and boiling point of these non-metals is less as compared to metals. So, metalloids. So, what are metalloids, students? Tell me. Again, in the last class, we have discussed metalloids. So, there are three types of substances, right? What are the three types of substances or three types of elements? Three types of elements are metals, non-metals, and metalloids. Metals, non-metals, and metalloids. So metals we have studied yesterday, non-metals we have studied today, and again these are metalloids. So what are these metalloids? Metalloids are the elements. Okay, these are the elements which have the properties of both metals and non-metals. Okay, means half of the properties will be of metals and half of the properties will be of non-metals. Means it is a combination of metals. Some of the properties will be matching with metals and some of the properties will be matching with non-metals. So metalloids have properties of both of these. Then you can see some examples are given. Some elements such as arsenic is there, silicon, germanium, antimony. Okay, so these are the metalloids. Now next is the chemical properties of metals. Chemical properties of metals. Then here we need to study about the chemical reactions. In chemical properties, we need to study about chemical reaction means how they are chemically combining with other elements. In chemical properties, what you have to study? You have to study about chemical combinations, how these metals are combining with other elements to give a new compound. So electronic configuration. What is electronic configuration? What do you understand by electronic configuration? What do you understand by electronic configuration? It is the arrangement of electrons. It is the arrangement of electrons in an atom. We know that atom is made up of what? Protons, electrons, and neutrons. Okay, atom is made up of protons, electrons, and neutrons. So protons and neutrons are present in the nucleus. Okay, suppose this is a nucleus. So protons are present here in the nucleus, and again neutrons are present here in the nucleus, and now these are the shells which are also known as orbits. The shells or orbits in which electrons are present. Okay, so this black color is been shown here, which is electrons. Okay, so these are electrons. So arrangement of electrons in an atom, it is known as electronic configuration. So electronic configuration is very important in case of chemical reaction because every element react in a different way. Every element reacts in a different way, and it depends upon the electronic configuration how the element is going to react. So if you see the metal, three metals are shown here. Sodium, Na means sodium, Na means sodium, Mg means magnesium, and Al means aluminium. Sodium, magnesium, and aluminium. So these are the three metals. Now atomic number. See, atomic number is given 11 of sodium, 12 for magnesium, and 13 for aluminium. So this atomic number tells you about the number of electrons. This atomic number tells you about number of electrons which are present inside the atom. Number of electrons which are present inside the atom. So how is the electronic configuration? Means how the electrons are arranged. See, it is 2, 8, 1. So what does this mean 2, 8, 1? I'll show you with the help of diagram. So this is the nucleus. Suppose this is the nucleus. Okay, and what is the arrangement given here? 2, 8, 1. It means first shell has 2 electrons. First shell has 2 electrons. Second shell has 8 electrons. Second shell has 8 electrons, and third shell has only 1 electron. Third shell has only 1 electron. So this is the electronic configuration. So what I am explaining is why it is written as 2, 8, 1. So it is the number of shell. First shell may 2 electrons, second shell may 8 electrons, and third shell consists of only 1 electron. So if it is 2, 8, 2, it means the last shell, that is second shell, consists of 2 electrons. Okay, first shell 2 electrons, second shell 8 electrons, again third shell will also contain 2 electrons. Now, if it is 2, 8, 3, it means a first shell will contain 2 electrons, second shell will contain 8 electrons, and then third shell will contain 3 electrons. So it is like that, the electronic configuration. Next is formation of ions. Metals have a tendency to lose valence electron to form the positively charged ions, that is cations. So this is the property of metals, that they lose their valence electrons. They lose their valence electron. Now what is valence electrons? Students, are you able to hear me? Reply me. What do you understand by valence electrons? You know about valence electrons? Are you listening? Okay, valence electrons is what? The number of electrons which are present in the last shell. Number of electrons which is present in the last shell. Now I'm drawing the diagram. Tell me the number of valence electrons. Okay, suppose this is the atom. Now tell me the number of valence electrons. How many valence electrons are present? Tell me. What is the number of valence electrons here? Yes, I want reply from all. Valence electron. सिर्फ valence electron बताओ मुझे. Okay, one answer. On is saying 2L. Other students, what you say? What are the number of valence electrons here? What I said is number of electrons in the outermost shell. What is valence electron? See, listen. What is valence electron? Valence electron is the number of electrons. Valence electron is the number of electrons in the outermost shell, bahar wale shell. So this blue color, okay, now do not write on the screen. See these blue color circles which I have drawn. This blue color circles which I have drawn, it is known as shell. It is known as shell. These blue color circles are known as shells in which the electrons are present. So how many shells are present here? Tell me. How many shells are there? How many shells are there, students? Three shells are there, right? How many blue circles are there? Three. How many shells are there? Three shells are there. And what I said is electrons in the last shell. Last shell मतलब क्या ये वाला shell? Okay, last shell means this shell. This shell is your last shell. Okay, last shell में कितने electrons है? How many electrons are there? Two. Yes, Pooja. Very good. How many electrons are there in the last shell? Two electrons are there in the last shell. So number of electrons which are there in the last shell are known as valence electron. These are known as valence electrons. So number of valence electrons here is 2. Number of valence electron is 2. Now tell me how many valence electron now? Say, see carefully and tell me. See the diagram and tell me. Yes, Pooja. Very good. Yes, on. Very good. So here only one electron is there in the valence shell. The number of valence electron is 1. So I hope you have understood now. Now see sodium. See here sodium. Sodium is there. What is the electronic configuration? 2, 8, 1. So number of valence electron कितने हैं? एक है इसमें है ना, last shell में एक electron है. So that valence electron will be released. That valence electron is released. So you see here, ये जो एक electron था वो उसमें से निकल गया. That electron has been removed from the valence shell. So this is a property of metals that whatever electrons are present in the valence shell are being donated. Donate हो जाएंगे, ठीक है? तो एक shell एक electron था तो एक electron is been donated here. And if you see this magnesium, this magnesium has two electrons. This magnesium has two electrons in the valence shell. So these two electrons are removed, right? So see this aluminium has three electrons in the valence shell. So three electrons are removed, right? Understood? Have you understood this? Any doubt? So after giving off the valence electrons, when the valence electron has been donated, okay, after giving off the valence electron, what happens? You see, here no charge was there on the sodium, but here one charge is there because one electron has been given, so one plus is there. If you see here two electrons are given, so you will see 2 plus. Can you see this? So here three electrons are given, so you have 3 plus. So these positively charged species, these are known as cations. These positively charged species, these positively charged species are known as what? Cations. These are known as cations. So this is sodium. First is sodium cation, second is magnesium cation, and third is aluminium cation. Next is reaction with oxygen. Next is reaction with oxygen. So here we need to see that metals, oxygen is present where? Where oxygen is present? Where oxygen is present? Oxygen is present in the air, right? Oxygen is present in the air. So when these metals are kept in the air, when these metals are kept in the open space, when they are kept in the air, what happens is they react with the oxygen and one new compound is been formed, and that the compound is known as metal oxide. When metals react with oxygen, when metals react with oxygen, a new compound is being formed, and that compound is known as what? Metal oxide. So metals react with oxygen to form metal oxide. So this is a chemical reaction of metal with oxygen. Next, next is reaction with acid. Next is reaction with acid. So again, reaction with acids. So we need to see the reaction of metals. First, we have seen the reaction of metals with oxygen, right? Reaction of metals with oxygen, and that is we are getting metal oxide. Second is reaction of metals with acid. So what you are going to get? You are going to get salt plus hydrogen gas. Okay, whenever any metal reacts with acid, what is formed? Salt is formed. Salt plus hydrogen gas is formed. Okay, salt plus hydrogen gas. Suppose you take any metal, I'm showing the reaction of metal. Reaction of metal is not given here in the textbook. Suppose we have any metal, sodium. Okay, sodium metal is there. You have sodium metal. And then you have HCl. HCl is the acid, hydrochloric acid. It is an acid. So when this metal is been reacting with acid, what will happen? Sodium chloride will form. What will form? Sodium chloride. Okay, sodium chloride is what? Salt. We know, no, sodium chloride salt. What we eat in with our food, the salt which is added in the food, that is sodium chloride. So when sodium reacts with HCl, what will be formed? Sodium chloride will be formed, and along with this, hydrogen gas will be released. What will be released? Hydrogen gas. Okay, hydrogen gas will be released. So this is the formation of salt plus hydrogen gas when metal reacts with acid. Any doubt is there here? Any doubt here? No doubt. Okay. Okay, next is reaction with water. So whenever these elements are getting reacted with water, okay, so they produce what? Again, hydrogen gas will be produced. Whenever these metals react with water, whenever these metals react with water, again hydrogen gas will be produced, and along with hydrogen gas, what will be produced? Hydroxides. What will be produced is hydroxide. Okay, so if sodium is getting reacted with water, sodium hydroxide will be produced. If magnesium is reacting with water, magnesium hydroxide will be produced. So this is the case. Okay, this is not getting erased. What has happened? So next is, students, we need to see the uh, properties of non-metals. Okay, properties of non-metals. It is chemical properties of non-metals. So again, electronic configuration. See the electronic configuration. So three non-metals are shown here: nitrogen, oxygen, and chlorine. Okay, these are non-metals: nitrogen, oxygen, and chlorine. So atomic number is also given: atomic number 7, then atomic number is 8, and the last is atomic number 17. Electronic configuration 2,5, 2,6, 2,8, 7. Now talking about formation of ions. So these will form anions. These will form anions. Anions means what? If you see here, it is negatively charged, right? Metals में क्या बना था? Positively charged बना था, right? If you remember, in metals it was positively charged. It was Na plus, then Mg plus plus, then Al plus plus plus. But in case of non-metals, it is Cl minus, O minus, O2 minus, and then N3 minus. So these non-metals, what happens? Non-metals accepts electron. If you see here, one electron is being accepted, gain हो रहा है, electron का combination हो रहा है. In case of metals, electron was released. In case of metals, electrons was released. Okay, electron was donated. But in case of non-metals, electron will be accepted. So this is the difference here in case of metals and non-metals. So in case of the metals, electron is given off. In case of non-metals, electron is taken. So next, oxygen is there. So oxygen will take 2 electrons. So here 2 minus is there. If it is taking 2 electrons, so 2 minus. If it is taking, see here it is 3 electrons, so it will be 3 minus. Here it is only 1 electron, so it will be only 1 minus. So depending upon how many electrons are accepted, minus sign comes. Any doubt here? Okay, then next is reaction with oxygen. So again, carbon is a non-metal. Carbon will react with oxygen to give carbon dioxide. Then carbon dioxide will react with sodium hydroxide to give sodium bicarbonate, sodium carbonate. So this is the main equation. That carbon non-metal oxygen के साथ react करेगा, so what you will get carbon dioxide. Okay, so this is the only reaction which is required. So here uses of metals and non-metal, students. So here you have to complete this just like activity that you have to write the use of any metal. Like suppose name of metal you have to write. Take the name of metal like gold. Okay, gold. Gold will be used in what? Gold will be used in making jewelries, right? Ornaments are there. Then again silver will be used in making ornaments, and then showpieces. Some silver showpieces are also used, right? Then you take example of copper. Copper wires are been made, which is used in electrical supply. So this is a use of copper metal. Then iron. Iron is used for so many purposes. In our house also, so many items are made up of iron. Some of the furniture is made up of different metals. So these are the different uses of metals. And then again, in case of non-metals also, you have to write some uses of non-metals. Any non-metal you can take, suppose take oxygen. Oxygen is a gas and it is used for the survival. It is used for breathing, right? So this is also one use of this non-metal. So in this way, you can find out some uses and then compute of this table. Then the part which is remaining here is noble metals. Okay, noble metals, and then uses of noble metal, then purity of gold. So noble metal means what? The metals which do not react easily with any other substances. Okay, metals which do not react easily with any other substances. If you see here, this sodium is there, magnesium is there, aluminium is there. It is easily combining with oxygen, है ना? ये जो ऐसे metals है वो किसी के साथ भी combine होके नया compound बना देंगे. But what are noble metals? Noble metals do not undergo reaction. Noble metals जल्दी से कोई reaction show नहीं करेंगे, किसी के साथ भी react नहीं होते. These are known as noble metals. So in the next class, we are going to study in detail about noble metals, then uses of noble metals and the purity of gold. Purity of gold, and then about corrosion and some type of alloys we are going to study. If you have any doubt now, let me know. Any doubt is there, students? No doubts, okay. No doubt is there. Then I'm ending the lecture here. Okay.